Okay, so today I will talk about partial fraction decomposition, and this is another method to solve integrals that can be solved by using simple u substitution. So this is simple rules for basic rules for partial fraction decomposition. If you have a fraction over 1 over a normal quadratic equation that can be normal quadratic function that can be factored out, you should factor out, and then this would be the partial fraction decomposition, where you would split the denominator into two parts, which you can later easily integrate easier. If there's a function that is repeated, you just do a over x plus 3 plus b over x plus 3 squared. And if there's a quadratic function, you should do ax plus b, which is a linear function, over x squared plus 5, which is a quadratic function. And if it's a cubic, you would do ax squared plus bx plus c over the cubic function. And you can only use partial fraction decomposition if it's a proper fraction. If it's an improper fraction, you should divide the fraction and then use partial fraction decomposition with the remaining fraction. So here's our first example: 2x plus 16 over x squared plus x plus 6. As you can see, you can't use a simple u substitution here, because if you do, your du is going to equal 2x plus 1, which is not the numerator. So since you can't solve it by a simple u substitution, and since it's a proper fraction, you can use partial fraction decomposition to solve this integral. So like we did here, we're going to set it up, we're going to rewrite it outside of the integral, and this factors out into 2x plus 3 times x plus 2. So that will give you a x plus 3. Wait, 1 second, sorry. This is wrong. This is supposed to be x squared plus x minus 6. So this will factor out into x squared plus 3 times x minus 2. So you'll split the denominator into ax plus 3 plus b over x minus 2. So after you do that, you wanna get rid of the denominator, so you multiply by the common denominator, and then that gives you 2x plus 16 is equal to a x minus 2 plus b x plus 3. So after you do that, you just continue. So ax minus 2a plus bx plus 3b. Then you can make a system of equations where these two will equal 2 because it has an x here, and these two have an x. So it'll be a plus b is equal to 2, and then negative 2a plus 3b will equal to 6, since this is a constant and these don't have x with them. So then when you solve that system of equations, you can just solve it normally. So you can make this 2, so that will be 2a plus 2b is equal to 4 minus 2. So that's a's cross out, and you got 5b is equal to 20, so therefore b is equal to 4. So now you have b, you can just plug this in the original equation, and you'll get a is equal to negative 2. So after you have the a and you have the b, you can plug it in back here in the fraction decomposition, and then so you'll plug those two fractions to make a simpler integral that you can actually just integrate easily. So this will equal a over x plus 3 plus b over x minus 2 dx. And we can do this because here we made a over this plus b over this our original integrand, so that's why we can do this. Anyway, so we found that a was -2 and b was 4. So -2 over x plus 3 plus 4 over x minus 2 dx. And then this just simply, by basic integration rules, it integrates to -2 the natural log of x plus 3 plus 4 the natural log of x minus 2 plus c. So that is the answer to the integral of 2x plus 16 over x squared plus x minus 6. So our next problem, our second example, is an example where our function is repeated, and that example is 5x over x plus 3 cubed. So as you can see here, this is just a linear function that is repeated 3 times. So it's not going to be ax squared plus bx plus c is equal to x plus 3 over cubed. No, it's going to be 5x over x plus 3 cubed is equal to a over x plus 3 plus b over x plus 3 squared plus c over x plus 3 cubed. And then just simply, we're just gonna do what we did before by x plus 3 cubed. And this will cross out with this, so it's gonna equal 5x is equal to a over x plus 3 squared plus b x plus 3 plus c. And then we carry this out and we find out that it's a plus x squared plus 6x plus 9 plus b x plus 3b plus c, which is just continuing ax squared plus 6ax plus 9a plus bx plus 3b plus c is equal to 5x. So here we have ax squared. This is our only x squared, so it's going to be a is equal to 0 since we have no x squared on this side. So a is equal to 0. And then 6a plus 6ax plus bx. So 6a plus b is equal to 5. So is equal to 5. And then the final left are 9a plus 3b plus c are also equal to 0. So that's 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. So this is going to be our system of equations. And since we just have a here, we automatically get that. So a is equal to 0, b is equal to 5, and c is going to equal -15. So now we can just plug these three things that we found, 3 solutions that we found, and make a new integrand. So the new integrand is going to be 5 over x plus 3 squared plus, minus 15 over x plus 3 cubed dx. And these are going to be solved using just u substitution. So this is just going to be, this is equal to 5 x plus 3 -2. You can take the 5 out because it's a constant. Minus 15 x, we can just do minus 15 x plus 3 -3 dx. You can also just take this out because it's a constant. So it's going to be 5, -5, because when we raise this, it's going to be a negative still. So x plus 3 -1 minus, it's going to be minus, but then it's going to be positive because this is a negative, and when you raise it, it's going to be -2. So when you divide it by -2, it's gonna be positive, so it's 15 over -2 x plus 3 squared, so plus c. So simplifying this, it's just gonna be -5 over x plus 3 plus 15 over 2 x plus 3 squared plus c is the answer to this integrand. And that is how you do partial fraction decomposition.